Welcome to the deep dive,
The deep dive.
where we kind of take that mountain of articles and notes you're looking at,
Oh, yeah.
and we try to chisel out the truly valuable nuggets.
Exactly.
You want to be informed quickly but thoroughly, right?
Right.
That's what we're here for.
Because honestly, who has the time
Yeah,
to wade through it all?
seriously.
We sift, you
Yeah,
gain.
Exactly. And wow, what a collection of material you've sent our way today.
It's something else.
It's like we're zooming in on the most personal connections between people and then instantly zooming out to the very edge of the observable universe.
The macro and the micro.
Right.
Yeah,
Prepare for some facts that'll make you think and some genuine aha moments.
you bet.
So our mission in this deep dive is to navigate this incredible range, to see if we can find like the hidden threads connecting seemingly unrelated ideas,
Right.
and ultimately to distill most important understandings from everything you've shared.
I love that.
Okay.
Distilling. Yeah.
Now, about these sources, it's a substantial amount of what we have as pasted text,
Uh-huh.
a real mix of subjects.
Yeah.
So no dilly-dallying. Let's jump right into it, shall we?
Let's do it.
Okay, so let's unpack this first area. It looks like you've been pondering how we truly connect with each other,
Uh-huh.
specifically the skill of intentional communication,
Yes.
which makes perfect sense, doesn't it?
It does, yeah.
I mean, the strength of our relationships, both in our personal lives and at work, really hinges on this.
It really does. It's kind of the bedrock of everything.
Yeah.
Intentional communication at its heart is about being fully present in the moment, completely engaged when we're interacting with someone.
Yeah.
You know, it might sound straightforward, but in practice,
Yeah.
it's surprisingly easy to miss the mark.
Totally, totally. Life's a constant stream of interruptions.
Yeah.
But the text highlights some key obstacles to this kind of effective communication,
Okay.
starting with what's going on inside our own heads.
Yes.
So what we're talking about here?
Well, you know, the first barrier mentioned is assumptions. We often think we know what someone else is thinking or feeling, and so we don't truly make the effort to hear their actual perspective.
It's like we fill in the blanks.
Exactly. We fill in the blanks with our own assumptions. Then we have distractions, our phones buzzing, the surrounding environment,
Yeah.
all competing for our attention.
Oh my gosh, don't even get me started. And who hasn't been derailed by emotional triggers?
Oh, yeah.
Someone says something and suddenly you're reacting emotionally instead of responding thoughtfully.
Oh, all the time.
Right,
And let's not overlook our inherent biases and prejudices.
right.
These act like filters influencing how we interpret messages, often without us even being consciously aware of it.
It's like we're wearing lenses that subtly distort what we hear.
Yeah. Yeah, a good analogy.
And then there are the external factors,
Right.
the things outside of ourselves
Mm-hmm.
that interfere with clear communication.
Exactly.
Yeah.
Simple things like background noise
Yeah.
and interruptions can make it incredibly difficult to concentrate and truly listen.
Yeah,
Even the environment itself plays a role.
right.
A quiet setting naturally encourages deeper engagement than a crowded, noisy space.
Totally, yeah. So we've identified the hurdles.
Mm-hmm.
Now, what does the text suggest are the key skills we need to actually master this intentional communication thing?
Well, 3 fundamental skills are highlighted: active listening, empathy, and clarity in expression.
Okay.
And they really build upon one another.
So active listening.
Yeah.
It's so much more than just waiting for your turn to speak, isn't it?
Oh, absolutely. Absolutely. It involves paying close attention, not just to the words being spoken, but also to the speaker's tone of voice, their body language,
Right.
and the underlying emotions they might be conveying.
It's the whole package.
It's being fully present in the conversation,
Yeah.
asking questions to clarify your understanding, and even summarizing what they've said
Oh, yeah.
to ensure you've grasped it correctly. The core insight of active listening isn't just about absorbing words,
Right.
but about understanding the unsaid needs driving those words,
Oh, interesting.
which is crucial for conflict resolution and building trust.
Okay, and then there's empathy. We hear that word a lot, but what does it truly mean in the context of intentional communication?
Well, in this context, it's about putting yourself in someone else's shoes, genuinely trying to understand and even share their feelings.
Uh-huh.
It's acknowledging their emotions and demonstrating that you are invested in their well-being. The key insight here is that empathy isn't just feeling for someone, but understanding with them, which requires suspending your own judgment and truly inhabiting their perspective. This shift can fundamentally alter the dynamic of any interaction.
I like that, feeling for someone versus understanding with them. That's a really good distinction.
It can really change things.
Now, the text even includes a personal anecdote about resolving a misunderstanding with a friend through the power of active listening and empathy,
Oh, nice.
which ultimately strengthened their friendship. It serves as a powerful reminder that these aren't just abstract concepts.
Right.
And that clarity and expression is the third crucial element.
Yes.
Being clear and concise in what you say helps prevent misunderstandings from arising in the first place.
Oh, definitely.
So how do we actually translate these skills into real-world practice?
Right.
The text outlines some practical strategies.
Right.
What are we talking about here?
Setting clear boundaries is essential. This means dedicating specific time and space for important conversations where you can both be free from distractions. It's also about approaching conversations with an open mind, genuinely willing to learn and understand other viewpoints rather than just pushing your own agenda.
Creating that safe and supportive environment
Exactly.
where people feel comfortable opening up and knowing they will be truly heard. Makes complete sense.
It does. And it all circles back to the recap in the text. Being present, engaged, and empathetic.
Yeah.
By consciously focusing on active listening, expressing ourselves with clarity, and being attuned to the emotional landscape of the conversation, we can undoubtedly cultivate stronger and more meaningful relationships.
Right.
Like any skill, it requires consistent practice, but the positive impact on our connections with others is well worth the effort.
Okay, so we've taken a deep dive into the art of connection here on Earth.
The art of connection, I like that.
Now, brace yourself for a dramatic shift, because we are about to embark on a cosmic journey
Okay.
of truly epic proportions. The text takes a sharp turn here, whisking us away from interpersonal relationships to the almost unimaginable vastness of outer space.
A truly breathtaking change of scale.
Right.
Underscoring the remarkable breadth of topics contained within the material you've provided.
It's amazing, right?
It is.
Our first port of call on this stellar voyage is alongside some truly pioneering spacecraft, those incredible machines that have ventured far beyond the familiar boundaries of our solar system.
I love this part.
The text mentions New Horizons reaching 50 astronomical units. Now, for those who might not be entirely familiar, what exactly is an AU?
So an astronomical unit, or AU, is defined as the average distance between our planet, Earth, and our star, the Sun. So when we say 50 AU, we're talking about a distance 50 times that, truly out in the cold, dark expanses of our solar system. And New Horizons holds the distinction of being the 5th spacecraft to travel that far, following the remarkable journeys of the Voyager and Pioneer probes.
And these aren't exactly new kids on the block, are they?
No, they're not.
Pioneer 10 and 11 were the first to cross that 50 AU milestone way back when.
Way back.
It's almost surreal to contemplate these small human-made objects traversing such immense distances. And the text points out that none of these pioneering spacecraft are ever expected to return.
That's correct. They are all on escape trajectories, meaning they have achieved sufficient velocity to break free from the sun's gravitational pull and are now heading out into the vastness of interstellar space.
So they're just on a one-way trip.
Essentially, yeah.
Wow. New Horizons, launched in 2006, had its primary objective to explore Pluto and its moon Charon.
Right.
A mission that was a phenomenal success, providing us with our first detailed glimpses of those icy worlds.
It was amazing.
It even utilized a gravity assist maneuver around Jupiter, not only boosting its speed, but also sending back incredible images, and even a video of a volcano erupting on Jupiter's moon, Io.
Spectacular, wasn't it?
Oh, those were amazing. That was really a turning point, I think, for a lot of people in terms of getting excited about space exploration again.
Absolutely. And New Horizons is still operational, continuing its exploration of the Kuiper Belt, sending back valuable data on fascinating objects like Quasar and Arrokoth, and even making measurements of the distances to other stars. Sadly, however, its power source is gradually depleting, and it's anticipated to fall completely silent by the year 2038.
So in a way, these spacecraft are like time capsules.
They are.
Or like messages in a bottle.
Yeah, that's a good way to put it. They're carrying the hopes and dreams, in a way, of humanity out into the cosmos.
I mean, they represent our first tentative steps out into the wider universe, right?
You do.
Speaking of firsts, Pioneer 10 holds the distinction of being the first spacecraft to successfully navigate the asteroid belt.
Wow.
And the first to conduct a flyby of Jupiter,
Right.
sending back those now iconic photographs of the giant planet.
Those were incredible.
It even crossed the orbit of Neptune and transmitted valuable data about interstellar plasma.
Yeah.
Currently, it's incredibly far out at 127 AU, and still moving outwards, although it's no longer communicating with Earth.
And Pioneer 11 wasn't far behind in its achievements,
Oh, right.
also visiting Jupiter and then going on to Saturn,
Yeah.
where it made the discovery of new moons and provided us with crucial data about Saturn's complex ring system. These early Pioneer missions were truly groundbreaking, paving the way for all that has followed.
Then we have the Voyager probes, those truly legendary twins of space exploration.
Yes.
Voyager 1 has ventured even further than any other human-made object, leaving behind the Kuiper Belt and crossing the heliopause.
That crucial boundary, where the sun's energetic solar wind finally gives way to the pressure of interstellar space.
It's hard to imagine, isn't it?
It is, and it now holds the record for being the most distant object we've ever created, and the fastest to leave the gravitational influence of our sun.
Truly remarkable, and Voyager 1 provided us with invaluable insights into the nature of the heliopause, studying the intricate interactions between the outward flow of the solar wind and the interstellar gas that permeates our galaxy. But similar to New Horizons, its power supply is expected to cease functioning around 2025.
And it's estimated that Voyager 1 will reach the inner boundary of the Oort cloud,
Yes.
that vast spherical reservoir of icy bodies located far, far beyond the planets in approximately 300 years.
Wow.
And it will take perhaps another 30,000 years
Oh my goodness.
for it to traverse the entirety of this immense region.
It just boggles the mind, doesn't
Yeah,
it?
it does. And it's not just aimlessly drifting. In roughly 40,000 years, it's projected to make a relatively close flyby of the star Gliese 445. It's mind-boggling, it really is.
And Voyager 2 embarked on its own incredible grand tour, visiting not only Saturn but also Uranus and Neptune, utilizing a gravity assist from Jupiter along the way.
The grand tour.
It really puts into sharp perspective just how mind-bogglingly vast the distances in our solar system, let alone the galaxy, truly are.
Yeah.
Even after decades of continuous travel, these pioneering probes have only just scratched the surface of our solar system's outermost reaches.
It's true.
And the text then shifts its focus to the immense and multifaceted challenges inherent in interstellar travel itself. It's clearly not as straightforward as simply building a bigger, more powerful rocket, is it?
Absolutely not. Our current chemical rocket engines have essentially reached the limits of their efficiency for such colossal voyages. Achieving true interstellar travel will necessitate the development of fundamentally different and far more advanced propulsion technologies. The text mentions intriguing concepts like nuclear pulse propulsion and solar sails, but both of these approaches present significant and complex hurdles in terms of practical implementation and engineering.
And then there's the absolutely crucial issue of energy.
Right.
These incredibly long journeys lasting decades, if not centuries, will demand stable and exceptionally powerful energy sources.
Absolutely.
I mean, how do you even begin to think about that?
Our current deep space probes rely on radioisotope batteries, but these inevitably degrade over time.
Sure.
The International Space Station utilizes a combination of solar panels and radioisotope generators, but its energy needs are primarily for life support within Earth's orbit.
Yeah.
Deep space missions venturing to other stars will require vastly greater amounts of power.
And the sheer emptiness of interstellar space means that there are no readily accessible energy sources to tap into along the way.
Right, exactly. Even the light from distant stars is incredibly weak by the time you reach interstellar distances. We will need autonomous, extraordinarily powerful, and ideally virtually inexhaustible energy sources to even contemplate making interstellar travel a practical reality.
Okay, this leads us to a truly fascinating and potentially revolutionary concept discussed in the text.
Okay.
The Casimir effect.
The Casimir effect.
It almost sounds like something straight out of science fiction.
It does, doesn't it?
The idea of generating usable energy from what appears to be absolutely nothing.
It sounds like magic, but it's actually a well-established phenomenon rooted in the principles of quantum physics.
Okay, so help me understand this.
Okay.
What is actually going on here?
The Casimir effect, first predicted and then experimentally verified in the last century, describes the surprisingly measurable attractive force that exists between two very closely spaced, uncharged conductive plates in the near-perfect vacuum of space. This force arises from the peculiar nature of fluctuations in the quantum vacuum.
Okay, let's try to break this down a little.
Okay.
Quantum vacuum fluctuations. That sounds like a lot of technical jargon. What's actually going on at a fundamental level?
Essentially, according to Heisenberg's uncertainty principle in quantum mechanics, even in a region of space that we perceive as a complete vacuum, pairs of virtual particles are constantly and spontaneously popping into and out of existence
Okay.
for incredibly brief moments in time.
This is not truly empty.
It's not empty. There's a seething cauldron of activity.
Okay.
And in the vast emptiness of open space, virtual particles with a virtually infinite range of wavelengths can momentarily appear.
Uh-huh.
However, when you bring those two conductive plates extremely close together,
Okay.
only those virtual particles whose wavelengths fit precisely within the tiny gap between the plates can actually exist in that restricted space.
Okay.
It's like a filter.
Okay, so if I understand correctly, there are effectively fewer types of virtual particles that can pop into existence between the plates
Yes.
compared to the space outside of them.
Exactly.
And this creates some kind of pressure differential.
It does. The more numerous virtual particles existing outside the plates exert a slightly greater pressure on the outer surfaces of the plates than the fewer virtual particles existing in the gap between them.
Okay.
This subtle imbalance in pressure results in a net attractive force pulling the two plates towards each other,
Wow.
effectively a kind of negative pressure.
And this seemingly minuscule force can actually be harnessed to generate energy.
Yes.
The researchers from Princeton and Hong Kong that you mentioned were able to generate a tiny amount of electrical current from this effect, weren't they?
That's right. They engineered a microscopic mechanism involving meticulously crafted silicon plates with interlocking teeth separated by a mere 100 nanometers.
That's incredibly tiny.
It is incredibly tiny. And they were able to demonstrate that the mechanical tension created by the Casimir force could be converted into a measurable electric current.
Right.
While the amount of current generated was indeed minuscule,
Right.
the underlying principle is nothing short of revolutionary.
Now.
The potential to extract energy literally from the quantum vacuum. Think of it like this. Imagine two boats very close to each other in a choppy sea.
Okay.
The waves hitting the outside of the boats will push them together more than the smaller restricted waves between them.
Right. Because the bigger weights can't fit between the boats.
Exactly.
So even a very low power but essentially inexhaustible energy source like this could have profound implications for long duration deep space probes, potentially powering their scientific instruments and communication systems for vastly extended periods.
It's true.
The text even playfully imagines the Voyager probes continuing to send back data for millennia.
Oh, wouldn't that be something? And the Casimir effect has even more intriguing theoretical implications, such as the predicted Scharnhorst effect, which suggests that under certain extreme conditions, the speed of light itself might theoretically be slightly faster between the Casimir plates.
Wait. Faster than the speed of light.
That's what the theory suggests.
I mean, that sounds like it could really upend our fundamental understanding of physics as we know it.
It's a mind-bending concept, but it remains a theoretical prediction arising from the complex framework of quantum field theory. The idea is that the absence of certain virtual particles between the plates might slightly reduce the probability of photons interacting with them, potentially allowing the photons to propagate ever so slightly faster.
Okay.
It's currently far beyond our technological capabilities to test experimentally, but it has fueled some truly far-out ideas, such as the concept of the Alcubierre warp drive bubble.
The warp drive. The staple of science fiction.
That's right.
How does the Casimir effect potentially tie into that mind-boggling idea?
Well, some theoretical physicists have speculated that by somehow manipulating the exotic properties of the Casimir effect using immense amounts of energy, it might be possible to warp the fabric of space-time itself. The idea is to compress space-time in front of a spacecraft and simultaneously expand it behind, creating a localized bubble of altered space-time that could effectively move faster than the speed of light relative to the surrounding undisturbed space.
So the ship itself isn't exceeding the speed of light locally, just riding a wave of warped space-time.
Exactly.
It's like cheating the cosmic speed limit.
In a way, yes.
But the text does mention that the energy requirements for such a feat would be astronomically high.
They would be.
On the order of converting the mass of an entire planet into pure energy, just to create a tiny functional warp bubble.
Precisely. The current estimations of the energy density required are indeed staggering. However, the long-term hope is that if we could find a way to significantly scale up the generation of energy through Casimir effect-like mechanisms to the required levels, we could theoretically obtain that energy from virtually any point in the universe, essentially extracting it from the seemingly empty vacuum itself.
So warp drive, at least according to our current understanding of physics, would require harnessing energy on a truly mind-boggling scale.
Yes.
Of course, Even if we somehow managed to unlock virtually limitless energy, interstellar travel would still face a host of other formidable challenges, wouldn't it?
It would, yes.
The text briefly touches on the dangers of deadly radiation in space, the constant threat of micrometeoroid impacts, and the immense difficulties of creating truly closed and self-sustaining biospheres for incredibly long voyages.
Absolutely. Interstellar space is permeated by various forms of highly energetic and potentially deadly radiation. Providing adequate protection for a crew on a multi-year or multi-decade voyage would likely necessitate either incredibly massive and heavy shielding or the development of sophisticated and powerful magnetic field technologies to deflect the harmful particles, both of which present their own significant engineering challenges and drawbacks. Then there's the constant risk of collisions with micrometeoroids and even larger particles of cosmic dust traveling at extraordinarily high velocities.
Right.
Even a tiny impact at those speeds can impart a significant amount of kinetic energy, potentially causing serious damage to a spacecraft's hull and critical systems.
It's a harsh and unforgiving environment out there.
It really is.
And for those truly ambitious, multi-generational starship concepts we often see in science fiction,
Right.
we would need to engineer completely self-sustaining ecological systems on board.
Yeah, it's a huge challenge.
While the International Space Station has made some progress with growing plants and recycling waste, creating a fully closed and balanced biosphere capable of supporting a thriving ecosystem for centuries remains a very distant dream.
It does. It's a truly monumental and multifaceted challenge.
Now, shifting our focus slightly, the text then discusses Earth's own unintentional reach out into the cosmos through the continuous broadcast of radio signals.
Uh-huh.
For over a century now, we have been steadily transmitting electromagnetic waves into space.
It's amazing to think about, isn't it?
It is. It's almost like we're sending out a continuous, albeit accidental, cosmic hello,
Right.
hoping that perhaps somewhere someone might be listening in.
Mm-hmm.
And our ever-expanding bubble of radio waves has already reached dozens of nearby star systems,
Wow.
even encompassing some that are known to host potentially habitable exoplanets. But the closest stellar neighbor to our Sun, the Alpha Centauri system, understandably remains a prime target for our more deliberate interstellar ambitions.
Absolutely.
So tell me more about Alpha Centauri.
It's actually a fascinating triple star system.
Whoa, I didn't realize that.
It consists of two sun-like stars, Alpha Centauri A and Alpha Centauri B, which are in a relatively close binary orbit around each other, and a much smaller and fainter red dwarf star called Proxima Centauri,
Right.
which is significantly farther away. Alpha Centauri A is slightly more massive and luminous than our own sun, while Alpha Centauri B is a bit smaller and cooler.
Uh-huh.
And interestingly, it emits a higher level of X-ray radiation.
I see.
Alpha Centauri A and B appear to the naked eye as a single bright star due to their proximity to each other.
And there's been a long and ongoing search for planets orbiting these stars. The text mentions some past excitement that ultimately didn't pan out, but there is still active research being conducted, right?
There is, yes.
Like the infrared evidence from 2021 that suggested the possible presence of a planet-like object orbiting Alpha Centauri A.
That's right. That object remains a planetary candidate at this time, and further observations are needed to confirm its existence and characteristics.
Okay.
Based on the preliminary infrared data, its estimated mass and size place it somewhere in the range between a super-Earth and a mini-Neptune, orbiting its star at a distance roughly similar to Earth's orbit around our sun. Hopefully, future observations with the powerful James Webb Space Telescope, or more sensitive Earth-based observatories, will provide us with more definitive data.
And what about Alpha Centauri B? There was that potential discovery of an Earth-sized planet orbiting it back in 2012 that generated a lot of excitement.
Right.
But it later turned out to be the result of a mathematical error in the data analysis.
Yeah.
It really highlights just how challenging and painstaking the detection of exoplanets can be.
It certainly does. It's a reminder that science is an ongoing process of discovery and refinement.
Then we have Proxima Centauri,
Right.
the small red dwarf star that is actually the closest individual star to our solar system,
It is.
located at a distance of, 4.25 light years?
That's right, 4.25 light years.
It's significantly smaller and much fainter than Alpha Centauri A and B.
It is, yeah.
And it has been found to host its own system of planets, including the intriguing and potentially habitable world known as Proxima Centauri B. Proxima Centauri B generated a significant amount of excitement in the scientific community when it was first discovered.
It did.
It orbits within the habitable zone of its red dwarf star. That's the region where temperatures could potentially allow for liquid water to exist on the surface.
Right.
However, being in such close proximity to a red dwarf star also presents some significant challenges for habitability, such as the likelihood of the planet being tidally locked,
Yeah.
meaning one side perpetually faces the star,
Right.
and being subjected to frequent and intense stellar flares.
It's a double-edged sword.
Hmm.
While Proxima Centauri b could potentially have liquid water on portions of its surface,
Right.
the intense stellar flares and associated bursts of high-energy ionizing radiation from Proxima Centauri could pose a serious threat to any potential atmosphere, possibly stripping it away over time.
Oh, so it could be habitable but not necessarily very hospitable. Okay. However, Proxima Centauri is also known to host another confirmed planet, Proxima Centauri c, which orbits much farther out, and there is also evidence suggesting the possible existence of a third planet in the system.
It's a fascinating system to study.
It's quite remarkable to think that our absolute closest stellar neighbor is not just a single star, but a whole system containing multiple worlds. But even at a relatively close 4.25 light-years away, the interstellar distances are still truly immense. The text reminds us that while our radio signals have been traveling towards Alpha Centauri for over a century now, the actual physical distance represents a formidable barrier to any kind of physical travel.
It does.
Light itself takes over 4 years to make that one-way journey. Our current generation of spacecraft, even the fastest ones, would require tens of thousands of years to cover that vast expanse.
It's a daunting prospect.
It is.
Yeah.
That's why truly radical and ambitious projects like Breakthrough Starshot, which the text mentions, are being explored. The revolutionary idea of sending a fleet of thousands of incredibly tiny probes, propelled to approximately 20% of the speed of light by powerful laser arrays based here on Earth, towards the Proxima Centauri system.
An incredibly ambitious and technologically challenging undertaking, but the potential scientific rewards are immense.
20% of the speed of light. That would dramatically reduce the travel time down to around 20 years for the probes to reach the system, with an additional 5 or so years for the data they collect to be transmitted back to Earth.
That's right.
It's still a multi-decade undertaking, but a truly massive improvement over conventional propulsion methods.
It would be revolutionary.
Now, expanding our perspective beyond the immediate Alpha Centauri system, the text broadens our view to encompass the local stellar neighborhood.
Okay.
The collection of approximately 50 star systems located within a radius of about 15 light-years from our Sun,
Right.
containing a total of 65 individual stars.
Lots of neighbors.
Many of these nearby star systems are now known to host their own exoplanets and are surrounded by protoplanetary disks, offering us a rich and diverse tapestry for studying the formation and evolution of stars and planetary systems.
A treasure trove of information waiting to be unlocked.
And our cosmic journey continues, taking us to Barnard's star, another red dwarf star located just 6 light-years away from us. It's notable for its unusually high proper motion across the sky,
It is.
the fastest of any known star relative to our Sun,
Yeah.
and the evidence suggesting the existence of an exoplanet designated GJ699b, which is believed to be a cold super-Earth.
An intriguing possibility.
So tell me more about this Barnard star system.
Well, Barnard's star is not only one of our closest stellar neighbors, but also one of the oldest stars known in our galaxy. While the potential exoplanet GJ699b is indeed likely to be quite cold due to the relatively low luminosity of its red dwarf host star, the possibility of a subsurface ocean of liquid water, heated by internal tidal